Okay, here we are, lesson 5.2. We're going to be solving systems of equations by substitution. So in your note packet, you see this key idea, and I want you to, I'll read them to you and I'll even abbreviate them if you want to try to keep up. Otherwise, pause the video and copy them down. So solving a systems of linear equations by substitution, step 1. We want to solve one of the equations for one of the variables. That means we need to have one of the variables isolated by itself. X is equal to something, or Y is equal to something like a slope-intercept form. Step 2, substitute the expression from step 1 into the other equation to solve for that variable. So what we're doing then is being able to, instead of having an equation with two different variables, get to an equation with one variable so we can solve it. Step 3, substitute the value from step 2 into one of the original equations. Once we know one variable, we just need to find the other. So pause the video if you're not done copying these down. All right, looking in our textbook at an example, you can see we have two systems right here. Y is equal to 2x minus 4 and 7x minus 2y equals 5. The first equation is already solved for y. So we could take that 2x minus 4 and substitute it in, right? Literally just stick it right there so that it looks like this. So we had 7x minus 2 times y equals 5. So now we can have 7x minus 2 times this 2x minus 4, because 2x minus 4 is equal to y. We can just use it to replace, substitute. All right, now we distribute this negative 2. All right, so we'll have a simplified 7x, and then we have minus 4x and plus 8 with some like terms. Notice that we only have one variable, x, so we can solve for x. Once we know what x is equal to, go back to this original equation, y is equal to 2x minus 4, substitute in this x that we just learned about. It's going to be 1 point on this line or the system where it's true for both, and solve for y, which is negative 6. Here's our ordered pair, and then the last step, you want to go back in and check to make sure that this makes sense and that it's true for both. Okay, so we are going to do this. Right here, we have two equations that are both solved for y. So it really won't matter which one I pick. I'll go ahead and say that I'm going to use this 5x from this equation, and I'm going to substitute that in right there. I'm going to literally replace this letter y. So I rewrite 5x is equal to 2x plus 3. Simple variables on both sides equation from chapter 1. So I subtract the 2x from both sides. I get 3x is equal to 3. And then I'm dividing by 3. Okay, so this is the same idea, these systems of linear equations. And in lesson 1, we graphed them and we looked at the place where the two lines intersected. Okay, well, sometimes that became difficult. Sometimes we were working on a graph and it went off the graph or whatever. And estimating by graphing isn't always easy. So we're taking these systems, right? We could have easily graphed these two equations, but we are solving it algebraically. We are using substitution. So this is just yet another method for solving the systems. All right, now that we know x is equal to 1, we could take that x and put it into, so we have y is equal to 5x. We could say y is equal to 5 times 1 if x is 1. That makes y equal to 5. And we have the ordered pair 1, 5. Okay? And we know that this is true. Okay, we know that this is true. I'm going to change colors here. If we come in and everywhere we see a y, we replace it with a 5. Everywhere we see a x, we replace it with a 1, right? And we double check it. Is 2 plus 3 5? Yes. Is 5 equal to 5 times 1? Yes. Okay. So that's a really important step because if you made a mistake somewhere, that's one way you could find it because it's not going to be true for both equations. All right, moving on to number 2. Y is equal to 1/2 x minus 5. So even though we dislike fractions, this is the isolated variable. It's already solved for y. So we want to go in and substitute that in there. So we have 4 times x plus 2 times y, and we're going to make it 2 times 1/2 x minus 5. So 4x plus 2 times 1/2 x minus 5 is equal to 0, and we'll distribute. So 2 times 1/2 is equal to 1, and 2 times -5 is -10. Combine like terms and just solve the two-step equation with inverse operations so that we get x is equal to 2. Okay, if x is equal to 2, we want to substitute that in right here, right? And we know that that is going to be half of 2 is 1. 1 minus 5 makes this a -4. So y would be equal to -4. So we know that it works for this equation. Does it work for this equation? Is 4 times 2 plus 2 times -4 equal to 0? Well, we have 8 plus -8, and that does equal 0. So we've checked it for both, okay? It's really important. I'm going to change colors here. Okay, this time in equation 3, or in system 3, we have x is solved for something. And so we can use that, right? We do not have to, solve it for y. We could solve it for and substitute it in for the x variable. So always pay attention to what variable is solved for. And we always want to look to see if we have to rearrange an equation, which we'll do in the next 2 examples, which one it's easiest to solve for. So I'm going to take, instead of 2 times x, I'm going to take 2 times 5y plus 3. And notice that when we do this, now we have an equation with just y. So we've substituted in, and instead of 2 variables, we have 1 variable, and that's the important part. So we're going to distribute here 10y plus 6 plus 6, oops, got a lot carried away there, didn't I? Plus 4y equals -1. Like terms are going to be 14y plus 6 equals -1. So 14y is equal to -7 dividing by 14. I see that y is equal to a -1/2, and that's okay. Now we have a -1/2 for y. So I'm going to maybe go into this equation. For this equation to solve for x, I probably should go into this equation. So we'll have x is equal to 5 times this -1/2 plus 3. All right. So when you take half of 5, right? So x is equal to, this is a -2.5 if you want to change it to a decimal. Sometimes that's easier. And then it's like taking 3 plus -2.5. 3 minus 2.5 is half. So x is equal to 0.5 or a positive fraction. So we have 1/2 comma -1/2. We already know that that works for the first equation. And so if we take half of 2 is 1, and then half of 4 is 2, but it's a -2. So 1 minus 2 is -1, and it works for the second. So always go back through and check. All right, moving right along. Okay, so this is the type of problem where it says, solve the system of linear equations by substitution and, um, x minus y is equal to 9, 2x plus 5y is equal to 4. Neither one of them are in slope-intercept form. Neither one of them are solved for a variable. So I want you to think about it. Which would be the easiest variable to solve for? What is the easiest variable that we could be solving for? So I want you to pause the video and answer the question. Okay, hopefully you said that you thought the easiest variable to solve for would be the x in the very first equation, and the reason why. It's positive, right? So we don't have to, when we solve and isolate it, we wouldn't have to come back and divide by a -1. Obviously, the coefficient of this y is -1. That would be the second easiest to solve for. Um, and that's probably about it. Sometimes you just have to get fractions. That's understandable. So we're going to solve for x. So to solve for x, I'm going to erase my little circle here. All right, we want to get x by itself, so we want to add y to both sides. So x is equal to 9 plus y. It doesn't really matter the order. We're not, because this is not slope-intercept form, but whenever you're doing and solving for y, I would recommend doing slope-intercept form. But now we can take this expression and put it in place of this variable, right? We're going to substitute it in. So we'll get 2 times 9 plus y plus the 5y is equal to 4. And we'll distribute 18 plus 2y plus 5y is equal to 4. Like terms, subtract 18. Now we have a positive and a negative, so we know that we have to subtract and then keep it negative. So -14. So when we divide by 7, we get y is equal to a -2. Now, if y is equal to -2, we can come up here and say x is equal to 9 plus this -2, right? And that makes x equal to 7. So x is equal to 7. So we have an ordered pair, 7, comma, -2 as our solution. Does it work? Is 7 minus a -2 equal to 9? Well, that's like 7 plus 2, it's 9, so it works for this one. Is 14 plus a -10 equal to 4? 14 plus -10 is equal to 4. So you could do some mental math calculations, okay? For number 9, what would be the variable, which equation would we want to solve for, and which variable do you think you'd want to isolate so that we could use substitution? Pause the video and answer that question. Okay, hopefully you said that even though this is a -1 coefficient, that's still going to be the easiest one. Notice that when we're dividing by, 2 or dividing by 3, 25 is not divisible by either of those, right? 15 is not divisible by 4. So sometimes you'll have equations that'll work out perfectly neat and easy, and it makes, they're all multiples or factors of each other. This is not one of those cases. So we're going to subtract the 4x from both sides. So -y is equal to -4x plus 15, and then dividing by a -1. So y is equal to 4x minus 15. We now have what we're going to substitute so that we can multiply by 3. So 2x plus 3 times this 4x minus 15 is equal to 25. And then use distributive property. 2x plus 12x minus 3 times 15 is 45 is equal to 25. Like terms. Ooh, add 45 and then divide by 14. So in this case, use your calculator to get x is equal to 5. Now, if we have x equal to 5 right here, we have y is equal to 4 times 5 minus 15. What's 20 minus 15? It is also 5. So y is equal to 5. our solution is the ordered pair 5, 5, and then we test it out. 2 times 5 is 10, 3 times 5 is 15, 10 plus 15 is equal to 25. 4 times 5 is 20, 20 minus 5 is 15, and we know that it's true. So that's the very most important step, is to check your solution to make sure that it is true.